Okay, modern physics review. This one, not a ton of calculation, so we're going to move kind of quick. I got to get this done in about 15 minutes. So, which characteristic of a light wave must increase as the light passes from glass to air? So, glass to air is the fastest. Light moves the fastest in air. Its index of refraction is 1.0. Glass has a higher index of refraction, so it has to move slower in glass. So its speed is definitely going to increase. But, so V is going to go up. All right, so V equals F lambda. All right, so if V is going up, frequency doesn't change, right? Frequency does not change going from one material to another. We can get rid of that. Amplitude, light waves don't really have an amplitude per se, and period. It must be wavelength that goes up because we know frequency doesn't change, so all the other ones also don't change pretty much. Amplitude of sound wave is most closely related to the sounds. Oh, the amplitude, ooh, that's energy I've been saying, right? Frequency is pitch. Wavelength would also be pitch, essentially. Speed is a constant. It's loudness, the energy. A duck floating on a lake oscillates up and down 5 times during a 10-second interval. So 5 cycles per 10 seconds. Now, there's not really an equation for that. It's just kind of the concept of what frequency is. So 5 over 10 would be half of a cycle per second. So it would be 0.5 hertz. 1 hertz is 1 per second, right? 1 cycle per second, or 1 cycle to the minus second to the minus 1. All right, gamma wave with and a microwave traveling in the vacuum have the same speed. All right, they're different waves. Gamma, micro, different waves. They carry different energy, different frequency, different wavelength. They must have the same speed if they're in the same medium. A student produces a wave in a long spring by vibrating its end. As the frequency of the vibration is doubled, the wavelength of the spring, well, speed is going to be constant. V equals F lambda, right? So if you're doubling the frequency to maintain the same product, you'd have to half the wavelength. Speed will be the same in the spring, right? That speed depended on the tension of the spring. It depends on the density of the medium, the tension in the medium, and so on, okay? Which 2 points of the wave shown in there are in phase? So in phase is 0 degrees or 360 degrees out of phase, or phase difference. So which of these are 360 degrees apart? Well, B and D. All right. A, B, and C are 180 degrees away from each other. D and E are 90. A and B are 90. C and D are 180. All right, so it's the ones that are on the same place in the cycle. That's the only option. As a longitudinal wave moves through a medium. So longitudinal wave, right, those are compression waves. All right, they travel this way. The medium gets displaced in the same direction as the motion. So the particles in the medium vibrate parallel to the direction of the waves. Long, right? Long. The other one is transverse. That's when the waves go up and down like water. So, nope. No, they're not transferred. It's 1. Wind blowing across suspended power lines may cause the power lines to vibrate at their natural frequency. This often produces an audible sound. I've heard that sound. Probably many of you have, actually. The phenomenon, maybe not a power line, but like a rope or something, like on a boat, or if you're ever carrying anything on the top of your car, a strap will vibrate. This phenomenon is resonance. You don't even have to think about that. That's resonance. Okay. Student listens to music from a speaker in an adjoining room as represented in the diagram. So somehow the sound's getting over there, right? So the speaker's putting out wave fronts, and then they bend, right? So the sound's going that way, and then you can think about it kind of bending out. right? She notices that she does not have to be directly in front of the door. This is spreading sound waves by the door is an example of diffraction. It's diffraction. The tighter the opening, the more the diffraction. What is the minimum energy required to ionize an atom in the N=3 state? Oh boy. Hydrogen atom. Okay. Energy level diagram. So N=3 is right here. So we're going from 3 to ionization. That's to infinity. So that potential energy is 0. When it's at infinity, the energy at 3, I don't know why I just wrote this, is 1.51. It's a little bit hard to see on here. It's right here. It's this one. So the electron's here. We want to ionize it. So it's got to go from negative 1.51 up to 0. Okay? So it would have to absorb 1.51 EVs in order to get kicked up high enough to be ionized. Good question. All right, so we're only 5 minutes in. We're doing well. No real one calculation, right? The horn of a moving vehicle produces a sound of constant frequency. Two stationary observers, A and C, and the V, B, blah, 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 blah. Compared to the frequency of the sound of the horn heard by the driver, B, the frequency heard by A is, all right, so B, he's moving, this is a weird question. We've never done this. If you were riding the Frisbee, you would hear the pitch just as normal when we threw it in class. Obviously not possible. So in your car, things sound normal. Now, what's happening here is the sound waves are getting compressed here, right? They're getting compressed as they hit C. They're getting expanded as they hit A. So moving away from A, so we got to make sure we're reading this right. This is half the problem here, making sure we're comparing frequency heard by A. It's going to be lower frequency, and compared to the frequency sound heard by a driver, okay, A is going to be lower, C is going to be higher. So higher frequency, lower. More waves are going to be hitting per second here. So higher pitch for C, lower for A. Now let's figure out which of these answers is the right one. So again, it's the wording of this that is the hardest part. So A is lower, so let's just cross off ones that we can eliminate first of all. And the frequency heard by C is higher. Okay, that's a weird one. I don't love that one. Anyways, let's move on here. Okay, it shows a ray of monochromatic light. Instant, I had to make this one kind of small because I wanted to fit these all in here. Which ray best represents the path of the reflected light? A. All right. No other questions? I would say that's the refracted right there, right? I know it would be that one. That would be the refracted. You got to be careful. This says reflected. They're trying to get you to read it as refracted. This refraction one, I know that it has to bend towards the normal because we're going from air to glass higher. All right, a ray of yellow light travels at a speed of 2.4 meters in what material? We got to solve for the index of refraction, or C over V. So it's 3 times 10 to the 8th divided by 2.4 times 10 to the 8th. So let's get the index, then we'll go to the table. So 3E8 divided by 2.04. E8 is 1.47. Let's go to the index of refractions here. All right, we just did this stuff, but it feels like it was ages ago. Oops, wrong. Not a coefficient of friction, is it? 1.47. We got glycerol and corn oil. Oh no, have we done it right? Well, I'm guessing that they only gave us one option, glycerol. Okay, blue light photon has a wavelength of that meter. What's the energy? E equals hc over lambda. Let me show you where I got that. It's in the modern physics section here. Right here. Oh, nope, that's circuits, modern physics. E equals HF equals HC over lambda. Planck's constant, that's from the front of the reference table. All right, so Planck's constant right there. 6.63 times 10 to the negative 34th times 3 times 10 to the negative, or 10 to the positive 8th, divided by the wavelength, 4.8 times 10 to the negative 7. All right, so just, you know, it's going to, obviously, I think you can eliminate those two immediately, right? Those are way too big, so it's got to be one of these. And actually, we don't even have to put the whole scientific notation in. Watch this, 6.63 times 3 divided by 4.8 gives us 4.14. It's got to be that one, right? I can put the whole thing in, 6.63 E, and it might have, I'm surprised it came out 4.14. You know, maybe if it came out to 414 or 4,000, you know, you would know that would have to be the answer. Just because the coefficients, these are all factors of 10, right? That's just going to be the scientific notation. So that's just like a problem-solving strategy, right? You just throw if they're all different, just throw the numbers in there without the scientific notation if you just are afraid of making a mistake. But anyway, or not. There's the official answer. Yes, correct. Great. Diagram below shows waves A and B in the same medium. Okay, compared, it doesn't say what type of, okay, medium, so it's a mechanical wave. Compared to wave A, wave B has, so B has, let me draw a line in the middle here. B's amplitude is twice. So B's amplitude is twice. I'm going to eliminate 3 and 4, just cross those out just because I don't want to get distracted by them. Got to use these problem-solving strategies, right? Cross out the ones immediately that are wrong and work on half the answer at a time. Wavelength of B compared to wave A, so it's wave B's wavelength is appears to be half of A because one full cycle of B fits in A, so it's half the wavelength. B has half the wavelength. What is the quark composition of a proton? Oh man, it's nice. It's got to be +1, right? Proton's +1, so we talked about this. This is just kind of a memorization one, but we'll look at it anyways here. It's got to be made of, it's got to be positive. So up, up, down would be 2/3, 2/3. So it's +2/3, +2/3, -1/3. So it'd be 4 minus 1 is 3. So that one's probably the answer. Charm, strange, bottom would be a charge of 0. Up, down, strange would be a charge of 0 also. Up, down, down would be a charge of -1. So they didn't even give you another +1. You should memorize, though, that it's only up and down quarks. All right, so moving on here. Oh, man, I'm not going to make it in time here. I'll have to do this, pause this video maybe, and then shoot it again. So I'm pretty sure I have... Yeah, I got my physics class right after this. All right, I'll get through what I can. So it is longer than 15 minutes, so that's unfortunate. Two pulses approach each other in the same medium. Ooh, this one's going to give you guys trouble, I think. This one's going negative. This one's positive. So sometimes it's helpful to put a scale on here. +1, -1. This is going to cancel out that and leave us with just that. I bet a lot of you are going to say that. We'll see. Microwave oven emits a wavelength of an air. Calculate the frequency of the microwave. So V equals F lambda. All right. We're looking for F, so F equals V over lambda. The speed, it's in air, so F equals 3 times 10 to the 8th. This is 2 points, so you got to put all the units in here. Divided by 2 times 10 to the -2 meters. You don't need to put the 2.00. That doesn't matter. You don't get points off for sig figs on the physics regents. 3e8 divided by 2e -2. We get 1.5 times 10 to the 10th hertz. Calculate the energy equivalent in joules of the mass of a proton. Okay. In joules. So, E equals mc squared. All right. So mass of a proton, let's grab it here. mass of a proton right here. So it's 1.67 times 10 to the negative 27 kilograms times 3 times 10 to the 8th meters per second. It's gonna be squared. We did this one in class. It's always a good one to know. 1.67. Whoa, what did I do here? I wrote that backwards. I said 27 and I wrote 72. That's unfortunate. 67 e minus 27 times 3 e8 times 3 e8. Sometimes, you know, it's just better to multiply it by the same number twice. Okay. All right, page 3 went quick. Let's take a look at page 4. Won't make it through this. I'll have to pause it before the bell rings here, but we'll do it in class and I'll finish it up later. Use a protractor to determine the angle of refraction of the light ray as it passes from the unknown material into air. Great, not a protractor handy. I'll come back to this one. Calculate the index of refraction. Okay, we got to do that. I'm just trying to, I'll pause it at this point and come back to it.